All right, so I created a zip file for the class, and it is on Canvas. When you download it, it is going to, depending on which browser you are in, probably want to put it in Downloads. Once you have the zip file created, then you're going to want to right-click on it. This has 7-zip. There's WinRAR. There's WinZip. There's whatever, however many utilities. And in Windows, you can just extract all. And it should, maybe, uh-oh. And either that or I'm going to get 3 of them after I'm done. There it is. Oh, it came up on the other screen. I hate when that happens. All right, so we need a destination. You can put it in your documents or downloads. I'm going to leave it in downloads for this example since I closed out my first assembly. I'll work with this one. So once we extract it, now I have a folder inside of downloads that contains the ball bearing, the pulley, and then the 2 screenshots that I created. All right, so the problem with a compressed folder is that if you double click on that compressed folder and then double click on the assembly, it's going to create a temporary file. It's going to be buried in data, app data, roaming, SolidWorks, somewhere 10 levels deep. And at the same time, it's going to bark at you that it doesn't have the bearing. So if you get that bearing issue, make sure that you extract from the compressed folder into a for real folder. All right, so once we're through with, we can kind of keep the zip file as our archive, something I can go back to. But I'm going to go ahead with the open, and instead of documents, I'm going to navigate over to. And so when you're looking at the icon, and what am I? I'm in the large icons. Yeah, so a large icon. You'll see kind of more of the traditional folder as opposed to the the one with the zipper that says it's compressed. And then we'll grab the example. And then after I did that, I wasn't paying attention to what I told it, so I'm just going to make sure. Downloads. Oh, and then so when it extracted to the zip file name, and then to the folder name, and then to the parts. That is by virtue of the way that I created the file. And then we're going to have resolve mode, and I want to open up Pulley assembly, and then everything should load from there. All right. So at this this stage, the only other thing that we would really be concerned with is putting in the shoulder screw, and and then potentially a nut on the back side, and the fasteners for the tapped holes. Right, so that's not too big of a deal if we get to that point. All right, so when I go to save this, it should. I haven't made any changes, so let's go the other route, and I'll show you a couple ways. So with the virtual components, those aren't going to be easy to work with inside of the drawing. So I want to save part in external file. So right click on the file, and then save part. I'm okay with the names. Right now would be a good time if you didn't like plate 1 and plate 2 and you wanted to change the name. Now would be a really good time to do it. There's nothing tied to them, and they're not tied to an external in the assembly. Once I save the part, and then the pulley goes out, then I'm going to make sure it's going to the same as the assembly, and then hit OK. And then inside of my Windows, I'm going to see the pulley file pop up. So after doing that, if I hit save again, no, it's still not. So I was really expecting it to give me that that pop-up window that says, do I want to save externally? I really should have just done it right then. It's kind of a habit that I don't, because I want to go back through and check the naming. So if I select the first one and then hold down the shift button and select the third one, then I'm going to save part and external. That will give me all 3. Make sure it's in the same as assembly, and we'll hit OK. At that point, all of the little brackets disappear. Right. So like I said, there's a few things I need to resolve. Maybe there is a hook or another piece that I put out here to act as my interface. Um, I don't know if it's completely self-explanatory when I go to put this together, that the cable is going to come in this way and not go in this way and rub on the bottom of the pieces. So those would be concerns. All right, so setting up the drawings, we have a couple of options. I'm still not ready to jump into our DIM expert or the model-based definitions. We can apply dimensions and start to do the stack-ups, but I think the drawings are more approachable, at least initially. And then we get a little more comfortable and working into SolidWorks, then I'll give you the tips and tricks for applying directly out of each model. All right, so optionally, let's throw in an exploded view. So the third one over is the configuration tab, and then I give this a new exploded view. I can grab the first item, drag a little ways, grab the second item, drag a little ways. I don't know, maybe I guess the ball bearing can come out a little bit, as long as it doesn't look too, well, that's not very visible. Alright, so I'm just going to kind of manipulate these a little bit more. Alright, so it doesn't have to be crazy accurate. I'm a lot more obsessive compulsive when I'm designing for real. For a detail project, so I can save that back, and then we're pretty much ready to start creating our working document. So pick a drawing. The drawing template is going to come up and ask you for a sheet format, and at this stage the exploded view is not a requirement. It's, like I said, optional for illustration purposes. You want to go back and do it later, that's fine. You don't want to include it, I'm okay with that too. This really isn't the detail drafting how to make exploded views class. So we can stay with the landscape. Probably will end up giving you a sheet or a template to work from. And on the class computers, we haven't transitioned over to the view palette. So my assembly shows up in the model view, which is the same as coming up to view layout and going into model view. So when I pick this assembly, it's going to ask me what views I want to see, and well, other than I have the exploded view and the isometric. Yes.
I missed how you got there from the exploded view.
Oh, there was a file, new. Or you can come up to the icon and do new and grab a new drawing. Once the sheet format comes up, that's where you're going to A size, B size. We're good with all of them.
I missed how you got to the exploded view.
All right. So when you first start the drawing, then the model view comes up unless you have checked the start command when creating new drawing. If that is unchecked, you will have to come up to the view layout and pick model view. All right, so the other option is to come over to the view palette, and anything that is open, currently an available document in SolidWorks, you're going to be able to pick, and it's going to show you, notice it closed my model view. You're going to be able to pick those views and drag and drop them. I think a lot of people in industry have kind of like the view palette. I can go either way on that one. Model view comes up, I'm probably just going to use it. So I have a reference configuration as the default. We only have the one configuration, but if I had 2 or 3 sizes, I could drive all of that geometry out of this group. And then I'm going to show in the exploded state, because the first sheet of my document is going to be my bill of materials, my exploded view, the things that we're really going to look at. So I have the pieces, and then when you right click on the view and just right at the edge of the screen, the tables, and then it comes back, I'm going to create a bill of materials. Now, we haven't created anything in the way of a custom bill of materials, and on the other side of things, this has nothing to do with tolerancing, except that we're getting quantities, how many are in the assembly, and starting to point out this is where this thing goes. So I view my documents, my working documents, as roadmaps. If you look at one of my detail packages, typically it's going to be pick this part up first, turn the page, pick that part up, and those two parts go together. All right, I can't always achieve that, but a lot of times that is at least the intent. So a bill of materials standard is going to have a couple extra columns that I won't need. And this can be top level only because there's not sub and sub-sub assemblies or anything like that. And again, keep in mind this is the optional side. If you're going into the detailing, the drafting side, or on the manufacturing, wondering where all of this stuff comes from, this is how it's generating and managing that data. All right, so I really don't need the descriptions, so I should be able to double click on it just like in Excel. And if we had those fields, which is more of the SolidWorks class of what I would put in there, maybe material, which we didn't set materials, which would be a good thing to have right about now. I could feed in the materials. We have our quantities. Those are kind of the things that this is going to do for us. And then picking the view, I'm just kind of dragging it around to where it's a little bit more convenient. I'm not worried about the title block. And under annotation and going into the auto balloon, I would like to align everything to the left, see what that looks like. Okay, that isn't terrible, but maybe not great. And then clicking on any balloon will give you the magnet line that you can drag to. And my OCD is showing. I know I can't help but move that around just a little bit and make all those lines line up. All right. So I don't really care that there's 4 of number 5. I can kind of figure that out based on the quantities. And basically that sets up my first sheet. So at this point, if the company, the organization says you're going to create one file and save it, and there will be one sheet and associated sheets with this bill of materials, then we save the file and we pull a new document number and go again. I like the multi-sheet drawings just for the compactness, and so my next piece, I'm going to come down to next to sheet 1, this little box, and it says add sheet. That creates my next sheet, and I'm ready to bring in the other part. So let's see, on this one, the easy way is probably going to be to go into the File Explorer and go to the Open Items. And I want to pull the pulley, so this one is actually open. The pulley is an open file and available. If I were to come up to Window, I'm going to see the pulley, but the pulley part and the plates are residing in memory. So I can still drag and drop from that memory into my working document. So I'm going to have multiple views, and I'm going to go ahead and create, it's cylindrical, so I need pretty much a front view and either a top view or a right view. And we'll go ahead and accept. And I got my isometric view, so those look pretty good. And at 1 to 4 on the scale, not so good. So on the very bottom, and there again, my fingers are getting ahead of me, getting ahead of my mouth anyway. Very bottom, you'll see the 1 to 4 or something pretty close to it. When you click on that, that's going to give you access to the sheet views or to the sheet scales. And 1/2 scale is a little bit better. It's going to give me enough room to put in those tolerances and dimensions and be able to work from. It also created the center marks, and again, I don't want to get too far on the drafting. We've kind of taken it this far. It's hard not to go ahead and create this as a working document. So at this stage, we would create layer, And we would also create a dimension layer so we have that contrast and readability built into the document. So we'll add another one. My preferred method, and not everybody, I'm sure not everybody does it this way, but I tend to go through and pull in all of my documents. I set up all of my sheets so that I can see the entire package. All right, so the next sheet comes in, and then I'm ready to bring in, if I go to model view this time, then I'll need to browse and pull in plate 1. And plate 1, need to create multiple views. If that's not checked, it's only going to give me whichever view and switch to a projected view. So again, these were symmetrical. I'm not so much concerned about a front and a back. But once I get these, they're machined and we apply the tolerances, then whichever one has the flatness is going to go to the flatness of the pulley. The other one is going to go to the parallelism of the pulley. All right, and then because of the difference, I know I'm jumping back and forth. I want to kind of contrast these options. As we pulled one from the File Explorer, one from the model view, and then if I go back to the view palette, now there's nothing really there. The dot 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 will allow me to pick for plate 2. And then once I can see plate 2, this is a little bit different. I'm going to pull in the front view, and then it automatically is supposed to go into the projected view. And then I can drag out a right side view and an isometric view, and that will give me enough information. I can hit the check mark. And because of the notation, I get the 1032 tap, but that really doesn't give me all of the information that I want on that tap. Okay, and then the next one will be the standoff. And I'll just go back to the view palette for that one and pick the standoff. Again, this is a round part. It's pretty small. So we have its front view, its right side view. I don't really need a top view because it's going to be the same as the right side view. And then for this one, because it is so small, we're probably going to end up going the other way. Yeah, 5:1 actually doesn't look that bad. But of course the scale is a little bit interesting there. All right, so that gives me my 4 components. The purchase pieces are, we get what we get. We're not going to go through in detail unless there is a modification to a purchase part to make it work in our assembly. So if I buy it, it's off the shelf and I'm just going to put it in and assemble it. I don't need to reproduce the drawing. I want to have those items documented as far as the part numbers or a description, something a little, that will show up in the bill of materials that gives it traceability. But I don't really care where the tolerances come in, because we're building that into our, based on their specifications, we're building that into our documentation. All right, so to switch between the sheets, you're just clicking on the tabs across the bottom and seeing what those can work with. All right, we finally get to apply some tolerances somewhere. All right, so what are our critical dimensions? I come over to the annotation, and let's take a look at it from the standpoint. Oh, sorry. Side note is it's going to drive me crazy if I don't create the layers, so might as well go ahead and get it over with. Up in the upper right, you have kind of this gray area, and if you right click in there and come down to layer, that will add a toolbar to usually the lower left, and I can pull that out because I have not locked my toolbars. And this is very similar to AutoCAD, except that we won't end up with 50 layers. If I have 3 layers in SolidWorks, I'm doing pretty darn good. And so most of the AutoCAD drawings I've created, I couldn't get away with less than about 10 or 20, somewhere in there. All right, so when I click on it, very similar. I'm going to create a new. I'm just going to go center lines and find, I like the nice, really bright, annoying magenta. And then I'm going to create a dim layer. And that one is usually the blue. Pick colors you like. Things that you know, make sense. Or, you know, at the best case, the company already has a standard and you get their layer set up and you don't have to do anything with it. Okay, so I'm going to drag that back down into the lower left corner where it was. I'm currently in the dimensions, so any dimensions that I add will be on that layer. So things that are already existing, like the center marks, then I'm going to want to come over to its property manager, and at the very bottom, I'll change it over to center. And then now I'll have the nice, bright center mark for us to look at. All right, so when I start to think about this, I don't want to get into too far into true position. I don't want to get too far into kind of the mid plane of this V. So we're going to save that one. And we're going to save a couple of these to build up and into, and go a little further into our basic dimensions. So let's look at this from the standard tolerancing and see what we can get. And then as we decide what our critical tolerances are, we'll put a few dimensions on it and work through. And this project, you know, I kind of intend for this project to go into next week knowing that this is a lot of information, creating the drawing, getting that through, giving you a chance to work with it. So all right, so we're in the dimension layer. I'm going to pick up my smart dimension and we're at 4 inches. All right, so this does not have a standard 2-place, 3-place, 4-place fractional call out. So that's kind of a problem. So at 2 decimal places, industry standard could be 30 thousandths, it could be 15 thousandths, it could be 10 thousandths. Having super wide open tolerances, unless your manufacturing processes are going back to what you're using as a standard measuring instrument. If our standard measuring instrument is the tape measure, then yeah, I'm probably going to want to stay in 2 decimal places, but this isn't going to be very precise. We go to calipers, we're going to be a lot more precise. We go to micrometers, we're going to move up into that next level. So for the document, then I need to make a decision as soon as I see that first. And typically this would be built into the template. All right, so that's another whole conversation. There's another whole video, another whole thing that goes on with modifying and managing your templates. All right, so we already have enough information to deal with getting some dimensions on this. So all I really want to do is change everything except for the critical dimensions, the supercritical dimensions, over to 3 decimal places. So in the bottom right where it says inch, pounds, and seconds, or if you happen to open an ISO and it managed to read millimeters, grams, and seconds, we can switch back and forth there. Let's go ahead and check our drafting standard as it goes into the document properties. Under the drafting standard, we're within ANSI. A lot of times in the going back and forth, you'll see that I have ISO dimensions. It's really what you're comfortable with. I like some of the features of the ISO, some of them not so much. I like more of the ISO features than I do of the ANSI, so I tend to stay in ISO. But that's a personal preference and a decision that I make because I can. So under the units then, we are doing the inch, pounds, and seconds, and I want to set these as 3 decimal places as well. That changes the drafting standard to ANSI modified. All right, so if we go back up here, after we hit OK, it's just saying you made a change to it, and for this document, you now have this modified document, or modified standard. And our major move is that it went to 3 decimal places. All right, so that's a, plus or minus 5. That really is a standard plus or minus 5 tolerance. I'm not so concerned with it, and I'm getting my 20 minutes. So I will go ahead and save the document. And now this particular document, being a drawing, is going to save out as an SLD DRW. So at this point, we've created pretty much all 3 of our modules. We have the part files that were originally virtual components inside of the assembly. Were created in that assembly file, so the SLD ASM, and then that produced the part files, SLD PRT, and now we're saving this drawing package out to the SLD DRW. So when I hit save, and if I'm staying consistent with my naming convention, which is whatever I want to call it, then I will end up with the symbols that in Windows that show up as the parts, and then also the document that shows up as the drawing preview. So at this point, plate 1, plate 2, and the pulley have not been opened. They are residing in memory. They exist in the background. But until they're like 100% resolved, I'm not going to get that thumbnail picture. So really don't need the thumbnail picture. I'm not too worried about that one. And then we get to our first tolerance item. So I'm going to go into the smart dimension again, pick on the bore, and 875. Well, at its very best, this is now oversized, because remember that the ball bearing. See if okay, I'll come up in paint. That's fine. Our OD tolerance was minus 4/10 of a thousandth, so 875 minus 4/10. So if I cut that right at 875, slips in, and the hub of the pulley now spins on the outer race of the bearing, and the bearing does me absolutely no good. If I don't have that physical interference, that physical contact between the pulley and the outer race, what do I need it for? So when I come up to the tolerance, I really now I'm thinking about this in terms of what it needs to do, what I have for tolerance. So I would like the biggest that this can get to be probably 874.5, which would still be very loose, but more likely it's going to be an 874.0 to about 873.0. Thou to thou and a half press. That's still a pretty heavy press, but it will cover me on the tolerance so that I have at least a little bit of movement for that piece. So at this point, I've made a decision. I've made my first real tolerance decision here as to the function of that center bore. So right-clicking on the view and telling it to open the part will bring that part up, and I can go back to since I have the little dash greater than symbols, those are my external references. If I open any of those sketches, I don't have any dimensions. If I click on the object, it's an on edge. That tells me that it was converted and that it has that external reference. All right, so it's kind of one of those, depending on the capabilities of the designer, you may get a top-down assembly or a master model and have to deal with those external references. All right, so I need to go back to the assembly, and that one hasn't been saved either, so it wouldn't hurt to save documents as those pop up. And I really want to go back to the layout, and I don't have to go into the sketch to identify my dimension. If it's a little more complicated, I probably will. But let's just put it at 874. And when I rebuild and save all popped up on the other side, now when I go back into the drawing and to the sheet, I'm going to see 874. So I'll pause here for a second and we'll run through that again. Okay, so we applied the 874, and that is a press fit, but I need to um, my intention. The drawing does not show the intention that a bearing presses in there. Only by putting the tolerances on, because at this point it's still plus or minus 5. My high side on the analysis, my high side would be 879, and my low side would be 869. So I can't have that and have the bearing do what it's intended to do. So to that end, if I click on the dimension, I get all of its properties over on the left. And this is a good place for a, well, let's just run through them. So a basic dimension would show up as it's theoretically perfect, right? And so this is moving into the GD&T, but I don't have any modifier to say how is this basic dimension being controlled. I don't have a feature control frame attached to it just yet that says this theoretically perfect dimension can vary by this much because I've set that that control frame. So let's take a look at bilateral. And so it can't go higher, and then it can't go smaller. Well, I wouldn't like it to go any more than 1,000. And really, if I was doing the investigation on this, looking at the press fits, the light, all of our different categories of interference, light press, heavy press, I would be in the machinery's handbook, I would be in the engineering handbook, I'd be out on the internet, and I would be looking up that table saying that for a bearing of 875 in diameter, what is a nominal press and what is the range? And I would try to adhere to that standard so it's not so, I pulled it out of thin air and that's what I want. And when it doesn't work, I'm going to be upset about it. Well, that's not the way we play the game. So when I apply the minus 1,000th, that gives me a decent starting point. Right, but I would be more interested to see that we go into a limit dimension, which gives the high side and the low side, and that's pretty much what I want to end up with. Is I don't want it to be over 874, so I have at least that half thousandths, that 6/10ths, right? Because we had 875 minus 4/10ths on its tolerance, so we could be 875 to 874.6. Too many numbers. All right, should have wrote it down. All right, so that 6/10ths of a thousandths press to 1,000/6/10ths of a thou press, that may still be a little bit heavy, but until I go verify and check with check against the fits, I'm going to stand by that number. Symmetric dimension is a plus minus, and then when we come over min max, those are specific specific to that dimension, and then the fit, clearance, transitional press. Right, so I hesitate to jump right into the press fit, and these charts are this this level, mainly because when you start talking about H's and clearances, then you have to go into what it means. So we'll reserve that one for a little bit. Mainly I need to brush up on it. I know what I'm dealing with in theory, but seeing all those numbers, that's a little intimidating. All right, and then we come back, fit with tolerance, and then fit tolerance only. So for now, we're going to stay with the limit. I need to put my 1,000th on the low side back in. And then, oh, by the way, since this is really close, I would like to see it at 4 decimal places. That puts it into the machinist, that puts it into the person making this part that, hey, this is a pretty tight tolerance. All right, I see 3 decimal places, it's kind of, I can hit that. I could make this on the lathe and face it off, and then make a little fixture to hold on to it and clamp it in place and face off the other side, and it'll be fine. But going to 874 to 873, well, now I've got to put a little more effort into it, and that may increase the cost. I mean, I'm pretty much counting on it to increase the cost, holding that extra tolerance. It's going to take a little bit extra per part to get it to that level. All right. So to get us started, we have those form tolerances. And so what I want to control, what are my critical dimensions, I just called it out right here. As soon as I put that, hey, this is critical, then now I'm starting to think, how do I control that? All right, and then with our form tolerances, not always, but 99% of the time, we're going to pick something to be flatness to act as our primary datum. So that establishes the form, establishes where the datum is going to be produced. In our definition of a datum, that it is a feature that we can see, touch, and feel. At least, again, in most cases. There's always exceptions. There's always, that one case. But in good practice and beginning, I want something that makes sense. If I'm going to set it on the table and it sits there stable, then this is a primary datum. And so I would pick flatness across this face. All right, I would not pick the two little cylindrical arcs or the flats down here that represent that arc, because I'm not going to set that on end on my surface plate to measure anything and get any kind of accurate measurement out of it. And those are pretty much the three choices: the top, the bottom, or the diameter. And the V, nah, that's okay. Don't even want to talk about the V group. All right, so let's go with our geometric tolerance. And we're going to do pretty much what we've done on the last two, but now these are going to build up to the next level. Oh, I guess it would help to put a thickness on it. Since I did not do that, I have one more task to do before we set. So that ends up at 210. All right, we said that our opening is at 220. So if this was plus or minus 5, that means on the high side this would be 215, on the low side it would be 205. All right, so at the very minimum I'm going to have 5 thousandths clearance overall, 2.5 thousandths per side. Does that make sense? Or way too many numbers? All right, so I'm basically doing the quick math in my head. If I need to, I'm going to go back over here and let's go into the view layout, and I'll pull the pulley, and what I really want to see is a left or a right side view. And so when we start talking about the tolerance analysis, going through that process in its perfect condition, measuring between those two, 10, 5. All right, so there's 5 thousandths, there's 5 thousandths. If this grows to the high end, another 5 thousandths, that's going to pretty much cut these in half. If it shrinks, then it's pretty much going to double. 7.5. All right, so pulling numbers out of my head again. All right, so if we go from 210 down to 205, I'll have 7.5 thousandths clearance on each side. And if we grow to 215, then I'll have 2.5 thousandths on each side. All right, worst case scenario, the 2.5 is more of an issue than the 7.5. All right, the other thing that's driving is the standoffs. So the standoffs just took on a whole new, level of what we're going to do with those. All right, so I don't necessarily need to keep that view, but I'm going to be coming back to it for stack up. All right, so the 210, and this is a plus or minus 5 because when we put it down in the title block, it will say so. And so now I can think about it in terms of what I want for the tolerance. All right, so we're going to do a flatness, and we can attach the flatness to the extension line, or we can put it directly onto the surface. I tend to want to put these to the surface and have them separate from extension lines unless there's just a really good reason. And so when I bring that one down and out, let's see, I didn't add the numbers. Okay, so I'm just going to hit OK. See if we can position that a little bit better so it stays with the arrow as long as we're moving it around. But as soon as I get to kind of that perpendicular point and it jumps, then I can double click and we'll go back into the tolerance. And then we have to decide, are we going to be right at, with our plus or minus 5, the 5 thousandths flatness and 5 thousandths parallelism? Well, we're using up an awful lot of tolerance. So I wouldn't really carry it out to 2.5 thousandths. So that's kind of where a standard, you'll see a lot of drawings have 2 thousandths of flatness and 2 thousandths of parallelism. Right? It stays under the 5 thousandths tolerance, but keeps it tight enough that we won't be growing that tolerance zone outside of our standard tolerance that we just applied. Okay, so 2 thousandths. We go back in, and then this one is going to be parallelism, which is third over, second one down. And I'm just going to stay with that one. Oh, and what am I relating it to? I have to have that datum now. The form doesn't get a datum. It is, in effect, becoming the datum. We're establishing the datum. So, at this point, when I come over and pick the primary, then this is going to datum A. And I'm not worried about any of the rest of the boxes, any of the rest of the symbols right now. We're just kind of getting to that initial start point. So again, just making sure that I'm not picking something I don't want to pick. I'm going to zoom up, make sure that I can see it, and then we'll drag down some distance and hit OK. All right, and again, when I drag that away and back, that's going to set it to look more like an extension line. All right, so as far as the feature control frames, I don't really like to apply those to the extension line, but I have less heartache about applying a datum. All right, so the datum feature goes to the flatness side. And I really didn't think too much about the view if this, if we were looking at datum A. So datum A actually is the back side of the part. Does it matter? Probably not at this stage, but I want to at least consider it before I get too much further into it. All right, so we go into the 4 inches, and we do want to keep this fairly round, but it's really the V. And so I painted myself into a pretty good corner because I really didn't consider the V when I was going through this stack up earlier, as to this is really what I want to control. And so I need to control its center point, and also this is where the circularity, or the what amounts to these back-to-back cones, that is where my tolerance comes in. So I got to look into that one, because I don't know that one's, I've seen that one, or I haven't done that one very commonly. So so the center circle, let's just say that the outside is going to pull circularity, and we're going to keep it within 5 thousandths. We don't want it to be egg-shaped. I don't want it to be elliptical. And to that end, then we'll pull up the other form is circularity of 5 thousandths. Oh, and I didn't apply it, so I need to go back, since I got a little button happy there. It placed it where I had clicked, but I don't have a leader. So we're going to bring it to the property manager when I click on that frame, and I'm going to apply the leader. Then I can drag the leader over to the diameter and place it. All right, and then we will go with since that applies that way, how would, let's see, we go with the stack up. Well, I want to do concentracy, but the datum really isn't going to be for datum A. So I need to establish this as my datum A, or my datum B, so that I can go concentracy. For datum A, I could do perpendicularity so that this doesn't have an angle or have a taper. So let's do that one. I'll do that one first. Oh, I didn't want the datum. I wanted the tolerance zone. And so we go find the perpendicularity, and let's just keep it at 5 for now. And its relation is to A. And I'll apply it to the bore. All right, so we're still applying those to features. And then for the datum feature, when I go with B, I'm not sure about the correctness. You know, we established the perpendicularity. I assigned that to B because that's still the critical. Then in that case, really the circularity of cylindricity would be applied to this face, and then the outside would be the concentricity. So I have to work through the stack up of that because I could go either way with the application of the datum. So on the one side, which is going to be more measurable and be able to determine if it's able to hold the 5,000 circularity. All right. I have a decision to make. So for right now, until I verify, I'm going to see if I can get B off of that location. And if it's like the dimensions, I should be able to grab the grip. All right, so I had to zoom in a little ways, find the grip. And then the last one will be the concentricity. All right, so bottom left, we go into concentricity, and since this was 5,000ths, I'm going to also make it 5,000ths, but we need to really explore what that 5,000ths means, because if this can move within its tolerance zone, I could still end up with something that's not very balanced. Okay. Oh, and I missed that again. All right, we'll try again. And actually, let's see if I stack those up. Right, so if I apply it separately, perpendicular to A. So having seen that, let's go back to this one. And if I double click on it, forgot that I have that second row there. Concentricity. And we'll set that to datum B. All right, so now I have that stack feature control frame rather than feature control frames kind of stuck all over the place. All right, so we're going to call this one good. I have to do a little verification. Like I said, I didn't quite think the V through, and now I didn't really think which one I wanted to be the datum. So we'll come back to that if needed. So we've got a good start, and we still have 3 parts to go.